everyone, welcome to the last lesson of Chapter 8. In this lesson, we are going to be working with some trigonometric word problems. In this first example, we are going to model circular motion. Two people swing jump ropes, as shown in the diagram. The highest point of the middle of each rope is 75 inches above the ground, and the lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height h in inches of the rope as a function of the time t in seconds, given that the rope is at its lowest point when t is equal to 0. A sinusoidal function is the best function to model this motion because the height of the jump rope is going to start at the minimum and it's going to go up to the maximum, back down to the minimum, back up to the maximum, down to the minimum, and so on and so forth. The shape of the graph is going to be like a wave, so that's why we want to use the sine and cosine functions. And then we just have to figure out the relevant variables for our function. Recall that we can model sinusoidal function using either of these two, where a is the amplitude, b is the horizontal stretch or shrink, h is the horizontal translation, and k is our vertical translation. I'm going to first start off by finding the midline of the function. So in order to find the midline, you are going to take your minimum and your maximum and then add it and divide by 2. So the midline is going to be at y is equal to 39, so that tells us that our k value is going to be at 39. We also want to decide whether we are going to use cosine or sine. Now this is where we have to look at what we're given. We know that the rope is at its lowest point when t is equal to 0. So the y-intercept of the graph is going to be at the lowest point, the minimum. Because it is at the minimum and it's not at the midline, then we are going to use cosine. However, normally our cosine has a y-intercept at the maximum, but because in this scenario our y-intercept is at the minimum, we are actually going to have a reflection of the cosine graph. So this is going to be a negative cosine. Afterwards, we are going to find the amplitude and the period. In order to find the amplitude, we just want to see what is the distance from the minimum and maximum from the midline. So we can just take 39, subtract 3, and then we get 36. It also works if you do the maximum minus the midline. We also know that the rope makes 2 revolutions per second. This is going to help us find the period. That means that in half a second, the rope makes a full revolution. And 1 revolution is like 1 cycle. So that tells us that the rope completes a cycle in half a second. We're going to set this equal to 2 pi over b to find our b value. And you cross multiply, this will give you a b value of 4 pi. We also want to see if there's like a horizontal translation. Because we're using cosine and the function has a y-intercept at the minimum, we don't actually have a horizontal shift for us to consider. And now that we have all the relevant variables, we can write our function. So y is going to be equal to negative our amplitude, 36, cosine 4 pi t plus 39. Oh, this is actually supposed to be h of t. I'll let you guys try 4, and let's move on to the last example. In our last example, we are going to use a graphing calculator and perform a sinusoidal regression to write a function for a model. In example 4, the table shows the number n of hours of daylight in Denver, Colorado on the 15th day of each month, where t is equal to 1 represents January. Write a model that gives n as a function of t and interpret the period of its graph. Here we are given the table of values, and let's put this into Desmos. So I plotted the points, and now I'm just changing the axis just to change the view of the graph. Now notice that the points make like a wave shape, so that tells us that we are going to use a sine function. And I'm typing out the equation that you need to put in to do the sinusoidal regression on Desmos. You need to type in y1 tilde a sine parentheses b x1 plus c plus d. And then if you look down below, Desmos will give you the values for a, b, c, and d. After performing the sinusoidal regression on Desmos, I get this equation, or this model. N is approximated by 2.76477 sine of 0.51115 t minus 1.59106 plus 12.1329, where I got those A, B, C, and D values from the regression on Desmos. The last part of this question asks us to interpret the period of the graph. So in order to do that, we're going to take our b value and we're going to divide 2 pi by that b value. And I get around 12.2. This makes sense in terms of this function. We saw that it took about those 12 months for it to complete a whole cycle, and it makes sense because the cycle should be 12 months of a year. And that's it for our lesson for today. Let me know if you have any questions. Come to office hours if you need help. I hope you have a wonderful day and take care.